Dinosaurs return to the big screen, and it's time to think about what it meant to go to Jurassic Park. My name is Matt Borths, and this is Pastime. Jurassic Park was a gigantic movie and had a huge impact on the culture at large, but it also had a huge impact on paleontologists themselves. This is a movie that inspired probably hundreds of us to go on and really invest in what it meant to love dinosaurs. Around 1993, bookshelves exploded with the number of great new dinosaur books that came out to coincide with the release of the movie, and it really hasn't stopped since. But I wanted to offer a kind of non-paleontological perspective on the arrival of Jurassic World. In 1993, I lusted for Jurassic Park action figures. Like the new brainy Velociraptor and the sleek Tyrannosaurus Rex, they needed to be added to my toy box to replace these tubby tripod dino figures that I'd collected through my handful of birthdays, like 7 of them, and dozens of museum visits. And in 1993, the Jurassic Park dinosaurs were the state-of-the-art dinosaur models. But in 2015, the new Jurassic World toys are already scientifically obsolete. They are tokens of the 90s as quaint as old Spice Girls CDs. There's been a lot of discussion in the paleontological community about the scientific shortcomings of the dinosaurs and other prehistoric beasts found in Jurassic World. For example, the scientific consensus is that Velociraptor and its close kin were covered in feathers. Birds inherited their plumage because that's what their dinosaur progenitors had, not because feathers were required for flight. And there are so many fossils that document this amazing transition from the reptile-like ancestors of dinosaurs through the meat-eating dinosaurs into flighted birds. Birds are dinosaurs. And the bird-like dinosaurs should reflect that common heritage. Paleontologists also see Jurassic World as a missed opportunity to get the world caught up with some of the latest paleontological research and maybe introduce more actual dinosaurs to the public imagination. We've been working on this for 20 plus years since Jurassic Park came out, and there are so many animals that we'd love to share with the world. But instead, the movie conjures up a Indominus Rex, this kind of fictitious dinosaur, which is an amazing monster to look at, but maybe a missed opportunity to teach a little more about what used to actually live on this planet. For instance, before Jurassic Park, dromaeosaur dinosaurs could only be described to a non-paleontological audience as small versions of T-Rex. But Jurassic Park exposed the world to the word raptor. And the animals with the crazy toe claws could be admired on their own terms, even replacing T-Rex as my answer to the perennial, what's your favorite dinosaur stumper? I share some of the frustration experienced by my paleontological colleagues about this kind of inaccurate, old-school dinosaur portrayal. But I also wonder if we kind of miss the larger scientific impact Jurassic Park had on the public imagination, and maybe some of the expectations that we should have of Jurassic World as a piece of science fiction. Sure, Jurassic Park gave us these fast, smart dinosaurs, but the most important lesson came from a minuscule molecule, not the hungry, gigantic Brachiosaurus. Jurassic Park taught us about DNA.
Oh, Mr. DNA, where did you come from? From your blood.
When my new Jurassic Park dinosaurs joined my other animals, my play involved explaining the genetic modifications that led to the pink-spotted giraffe that was attacked by my T-Rex and the genes that had to be combined to make the Frankenstein-like dragon that swooped in for the kill. Jurassic Park taught me how to think about genes. I was 7, and I was thinking about genetic manipulation and what it meant to have DNA at the core of an animal. Jurassic Park built the foundations of a public understanding of genetics and framed the moral conversation that swirls around genetics and genetic engineering today. Before Jurassic Park, geneticists were limited by the words they could use to explain what they studied. The point of reference for most people was test tube babies and Brave New World. DNA was just 3 letters that had something to do with a ladder, maybe something to do with cells. But after Jurassic Park, millions of people knew that the ladder was the code of life. And that code was the perfect computer metaphor for a public embracing home PCs and listening to the first beeps of the AOL sign-in page. And just like a string of code, Jurassic Park showed that DNA could be hacked, and the implications of that power to manipulate life with just a few keystrokes made terrifying science fiction. While other pieces of pop culture have come along to teach the world about genetic engineering, none of them are among the top grossing movies of all time, like Jurassic Park is. And just as the world was equipped with a crash course in cloning thanks to Mr. DNA, it was also warned that these new technologies had serious implications, thanks to a venomous Dilophosaurus. Genetically modified foods, stem cell research, and modified human genomes are just a few of the genetic frontiers that scientists, policymakers, and the public have to wrestle with as we all come to terms with the powers our careful observations of biology over centuries have unleashed. But how much of the fear of genetically modified fish entering wild waterways and decimating the ecosystem really traces its roots to the image of raptors chasing kids through a kitchen, instead of a rational, thoughtful understanding of what new genetic engineering technology is giving us and the kinds of consequences we're dealing with when we use it? In the 1990s, a single company sequencing entire genomes of multiple species was as impossible as hatching a Tyrannosaurus rex. But in 2003, the Human Genome Project announced that they finally knew what was in our own species' genetic code. And now, that genome can be sequenced in less than a day. The tools for manipulating the genetic code are also changing rapidly as techniques like CRISPR allow geneticists to quickly target and change portions of the genome with greater precision than ever. We're not making dinosaurs yet, but the technology is being built in a way that has gone beyond the imagination of the best science writers of the early 90s. As Jurassic World rolls out, I know it won't change any cutting-edge conversations about Velociraptor, but I do wonder if it will help reframe some of the conversation on genetics. Genetic engineers have developed cancer-fighting gene therapies and drought-resistant crops. We are using the technology that was discussed and introduced to us first in Jurassic Park. And these scientists, they're not necessarily these hubristic automatons who are just pushing science frontiers because they can. They have real goals and real problems that they want to solve with this technology. But now, there is this need for a nuanced conversation about what we do and do not want to use genetic research to accomplish. It is an international genetic conversation, and it's a really hard one to have. But maybe an international movie that cost $170 million, like Jurassic World, is just the thing to help us have that conversation. Or maybe the movie's moral questions about genetic engineering and what it teaches us about what genetic manipulation can and cannot do, or should and should not do, will be just as retrograde as the dinosaurs on screen. So there's just a couple thoughts on the original impact of Jurassic Park. If you've been paying attention, you might have been a little worried about where Adam and I have gone. We kind of went on radio silence here for a couple of months and really haven't been as productive this year with Pastime as we would like to be. And that's because we're both in our final year of our PhDs, and we are in the final phases of trying to get these things done. So we haven't had a whole lot of time to work on Pastime, but we absolutely intend to be back at it starting in September. Think of that as our new season is going to be starting in September. Between now and then, we're going to try to put some stuff up on Twitter and put some stuff on Facebook, but there's not going to be a whole lot as we work on becoming certified paleontologist PhDs. There's plenty of other great content in the world of paleontology, and so check out the other podcasts on paleontology that are out there, as well as other blogs that we have links to on our website to get all of the latest information on the world of fossils. And then we'll be back to offer our Pastime perspective on it all. And with that, we'll see you next time on Pastime.